we are very privileged to have with us this evening someone who many of you know very well, and the society knows extremely well because he is a more than one-time winner of the BCS award. It's James Cheshire, and his talk this evening is entitled Mapping the Big Data Decade. Now, James is Professor of Geographic Information and Cartography at University College London, and he's co-author of a number of books which many of you will be familiar with, including London, the Information Capital, Where the Animals Go, and Atlas of the Invisible. He's received a number of prizes for his work, most notably the Cuthbert Peak Award from the Royal Geographical Society and the Corliss Beneficio Award from the North American Cartographic Information Society. So along with our own awards to him, he's a very highly decorated and a very prestigious speaker for us this evening. So James, I know that you're there. I'm going to hand over to you, let you share your screen.
Thanks, Seppi. Hopefully you can hear me, and thanks everyone for coming along. So yeah, I'll just share my screen. Thanks everyone for coming along. So this evening, I thought it'd be good to talk about what I'm referring to here as the big data decade. And why am I referring to it as that? Why am I talking about the decade? Well, it was a little over a decade ago that I gave my first ever talk to the BCS, which was in 2010. It was the Talking with Maps themed conference, which I think was in Nottingham, I remember. So I was a PhD student at the time, interested in this particular case, I was interested in how you could show what I'm referring to here as kind of large and multi-dimensional data sets in a single map. And my presentation was about some of the surname data I was looking at. And really, it was sort of from this point on that I started to get much more interested in how we might visualize through maps, some of the complex and big data that was increasingly becoming available around that time. And it was something I'd noticed a lot, even just as a PhD student. I was working with fairly large data sets and they were getting bigger and bigger. So there was, inspiration for getting involved in mapping and the BCS and others from this moment. And then around the same time, I was approached by a then graphics editor at National Geographic magazine called Oliver Uberti, who we'll hear more from later. And he's the person I co-authored the books with and has been jointly awarded the BCS prizes and others that we've worked on together. And so this is really how Oliver and I met. He was interested in some of the data I had on surnames, and they were piecing together this typographic map of North America. And what it revealed to me was the value of someone who knew a bit about data analysis, could look at big data sets and then extract value from them in such a way that someone like Oliver, who doesn't have a kind of a data background, he can interpret them and he can represent them in these different cartographic forms. And so it was the idea really that got me thinking about how do we use maps and maps to communicate some quite complex data sets to like a fairly broad audience. And so there are a number of kind of early projects I did that were fairly successful in terms of the number of people that saw them and the coverage they generated and the kind of the motivations that they gave me to continue mapping and map making to this very day. And so this was one of the first kind of big hits in a sense of a map that I'd created. It was widely featured in the media, and it was a map of life expectancy along tube lines So this is a geographic map of the tube, and I'd kind of interfaced life expectancy estimates there, and it was a kind of a London-wide version of a quite small extract of the tube map that Sir Michael Marmot originally came up with the idea for when he was talking about the variations in life expectancy along a few stops on the Jubilee line. But again, this was a kind of affirmation for me that if you can make data relatable, if you can take abstract numbers, in this case, something like life expectancy, if you make it relatable to people, you can generate a connection. And maps, of course, are one of the best ways of making things relatable, complex data, simplifying them in such a way that people can understand them. And so this is kind of a map of a fairly traditional data set. You know, life expectancy, we've been generating these kinds of data sets for a long time. But being able to map it this way, put it on the internet, share it widely, made a big difference in terms of how far it got and how many people saw it. But then around the same time, so we're talking sort of early 2010s, of course, many other things were happening to generate kind of new data sets that no one had ever seen before or even thought of as being possible. So this was another map, and that I'm amazed that it's still live. The website is still going strong, thanks in part to Oliver O'Brien, I think, who keeps it going. But this is now quite an old map that was created just around the time of the Olympics in London, so in 2012, looking at the languages that people were speaking on Twitter. So, you know, Twitter was still a relatively new thing. It was becoming more popular. But combining that with a language recognition algorithm to look at the words that were being used in the tweets, and then georeferencing the tweets and then mapping it, suddenly in this kind of very new and different way, showed some of the social structures and differences that were happening, you know, the people that were living in London, and even things like you know, the Olympic Park shines out here. You could see different parts of the athletes' village depending on, you know, the tweets that were coming out of that, and, you know, around Edgware Road, which had large numbers of Arabic being spoken, and so on. And so it was a really nice example of how, you know, big data suddenly revealed some of these structures that, you know, exist in cities. And of course, maps, again, are the best way of showing those structures through these kind of complex data sets. So we had some of the new kind of forms of data, social media data in particular, you know, really come to the fore in recent years. And I would actually argue that social media data has sort of passed its peak now. People have moved on to other different data sets. And a second phenomena that was happening at the beginning of the 2010s, which again was a real gift to mapping and map makers, was the open data movement. And so coming to the UK back in 2013, the UK was seen as a kind of a pioneer in releasing its data, government data sets. And of course, you know, the big one for us was some of the Ordnance Survey open data products. But this idea that you can share data widely for public benefit and also for commercial benefit, and leading to innovation. And I think it's led to a lot of innovation in mapping and cartography, as well as things like OpenStreetMap, of course. But this idea of openness in data, of sharing data, was and remains an important one. And again, maps become our tool for doing that. And so uniting these things together, this idea of the map becoming an important access point for a large and complex data set, combined with the availability of open data, which meant that you were no longer hit by prohibitively high licensing costs for sharing some of the geometry layers and things like that we might want to do on a map, combined with some of the additional context that things like OpenStreetMap were providing, that enabled us to create a website called DataShine, which again remains live and was probably the first kind of widely available, free at the point of use, publicly accessible map of census data. So this came out with the 2011 census. And so this was work that I completed with Oliver O'Brien, where we set this thing up to be ready to go for when the 2011 census results were released. And we were able to provide kind of drop-down menus for people to select and see different maps. And again, the innovation here is being able to see some of the building outlines and so on. Now, this is, there's pros and cons to whether this is offering kind of a bit too much precision, particularly around the census data, because of course it implies that we're releasing data at the building level and you get weird things appearing that may not be residential addresses and that kind of thing. But actually, undoubtedly, it's something that is a powerful way of showing the structures of our towns and cities. And again, is something that's now become widely adopted. I think most of the Office for National Statistics map outputs now use this kind of cartographic style. And we really wanted the map to be the window to the data that we were showing. And so we took the 2011 census quick statistics, we combined it with the Ordnance Survey open data, the Vector Map District, Meridian 2 and others. And we layered it up. And so, the power here was that people could then quickly create effectively choropleth maps within their web browser without the need to, use a GIS by manually joining data sets together. And towards the end, I'll think about the teaching, but this is and how teaching and cartography has changed. But this was a real game changer, particularly for my teaching, but also for secondary schools that still widely use this website, because it meant that there were kind of no overheads really in terms of the software that was needed. You just needed a functioning web browser, and you could straight away create kind of customized maps. And just alongside kind of open data principles, there was a kind of an open data geostack, and many of the tools here, again, back in the early 2010s, were very much in their infancy. Today, they've come on leaps and bounds. But again, this was kind of a pioneering approach before companies like Mapbox got underway in a big way, before companies like Carto and others who use similar technologies to these. And we had a couple of sort of power, what we described as power user features, which again made a big difference in terms of kind of the way that people could access the data, and you would have kind of more sort of professional users, for want of a better word, being able to create more nuanced maps. So we did this thing called local area rescaling, which enabled the colors to change according to the data that was in the web browser as you were looking at it. And that again was quite an innovative thing to be able to do at the time, because it required quite a lot of back-end work and data running in databases that were then served to the web browser. Queries were being run in the web browser and the map was changing. Nowadays, this is routine. It's very easy to do, but back then it was kind of a bit of a technological challenge. But one that we were keen to overcome. So we created different automatic kind of color binning strategies dependent on the distributions of the data. And it was really designed to tackle this kind of problem, where normally if you had a single map view of the country, you would have to create different, your color breaks to represent the national average. And if you had variables in the census, such as who travels to work by metro system, that includes things like the underground. You know, London is a very strange place by kind of national standards in the way that a lot of people behave. And so if you did a map of traveling to work by metro, you would just end up with a situation where London becomes oversaturated and everywhere else is somewhat undersaturated. And so the local area rescaling enabled us to account for some of these and create maps that had a bit more nuance in, particularly for areas that had things like, you know, tram networks and other smaller metro systems, enabling people to see that variation. And then the second thing was being able to download data. And that again was a real game changer, because prior to that point, you know, the way that you would get data from the Office for National Statistics, it was through clicking through multiple different tables with slightly obscure names. And then you may well download an area that isn't necessarily the one that you wanted. It's too large, doesn't quite conform to the geographical distribution, the geographic extent you wanted. And so you were then left kind of sifting through a spreadsheet. Whereas we implemented a system where you could zoom to the area you wanted, you could create the bounding box that you wanted, and then you would download the data straight away just for that particular bounding box. And then that enabled you to then go off and do the analysis. And again, this was a real, even just in terms of like enabling students to get data quickly, it's made it, this sort of thing made a huge difference. And we also, you know, innovated in other ways by doing travel to work flow maps. Again, this was a very large matrix of something like 10,000 plus, I think, origin destinations. Being able to get this into a web browser for everyone to access and to be able to look at different slices through the data, you know, who's getting to, you know, in this case, it's different travel modes on foot versus a taxi in central London. And so it enabled people to interrogate the data visually. And, you know, we even through these maps spotted, or at least people using the maps spotted some of the challenges with the data that the ONS hadn't fully been able to filter out themselves. And so, you know, they were alerted, and subsequent iterations of the data had these problems solved. And so this was really something that, you know, was a project that maybe took 2 or 3 years to deliver, of full-time work with Ollie O'Brien, who's a web mapping developer. Today, you know, this is something that can be done fairly routinely, fairly quickly with off-the-shelf tools. And so what was innovative, you know, within the last decade has now become very routine. And so I think that is something worth noting, because it has massively kind of liberated the possibilities of web mapping in a way that was only just beginning to start a decade ago. So in addition to thinking about the web map developments, I've also been working on 3 books, and these are the ones that I've been working with designer Oliver Uberti on, and the ones that have won the BCS prizes that were referred to. So I'm just half of a kind of a geographer designer team on these. And what's interesting is, you know, that the first book was London, the Information Capital, and then we had Where the Animals Go, and just out in the last couple of months or so, we've got Atlas of the Invisible. And the way that we've approached these books, even over the course of a decade, you know, some things have changed, but then some things have remained consistent, but actually quite a lot has changed in terms of what is possible for the kinds of data that we're looking at, and the big innovations that are happening there. So I thought I'd just reflect on some of those for the rest of this talk. So the first thing to say is that we're both very aware of and inspired by kind of pioneering cartographers, particularly in sort of the Victorian era, 1850s onwards. And the reason for that is they too experienced a kind of a similar world, that which was a world that was suddenly generating tremendous amounts of data that no one had previously. And that data was being generated by, a growing interest in the natural world, industrializing cities, technological innovation, and so on. And maps became an important characteristic for how this changing world was better understood. And so this is a map from, or a series of maps, I guess, from the Physikalische Atlas that was created by Berghaus at the request of Alexander von Humboldt. And so the brilliance of Humboldt and Berghaus's way of communicating Humboldt's ideas is this idea that you've got an Earth as a system. Everything's interrelated to one another, and we're interested in environmental data and contextual data and sort of thematic data, rather than just thinking about the locations of mountains and coastlines and so on. And so this was, a brilliant example of how you can take complex ideas and data and represent them in this kind of visually rich way. There are also some kind of really fascinating maps where you can see cartographers working through kind of new challenges as they occurred. So this is a cholera map that was created by Petermann, who was actually Berghaus's adopted son. And it's kind of one of the first, as many of you will know, it's one of the first kind of national maps for cholera in the UK, shaded in by cases, and really kind of representing kind of urban clusters, as they were, of cases of cholera. And you can see from the writing at the time and stuff, there was this realization that, disease was not random. I mean, they kind of thought that disease was an act of God. If you got sick, it's because you were leading an immoral life. And so these kinds of maps were the first examples where they were kind of having to work through the possibility that disease was caused by something else, and that something else may well be predictable, may well be presentable. And so sanitary reforms, and of course we know all the thinking and mythologies and others around the likes of Jon Snow, that work really was kind of map-based in the way that it communicated some of the additional data and stuff that was being collected at the time as well. And just as I mentioned before, that back in the early 2010s, we were thinking about visualizing data that previously hadn't existed. In our case, it was social media. In the case of the late 1800s, it was like new forms of transport. How do you represent, the flows of passengers on a railway network, and the health of an economy, and so on, with all these new forms of data that's being collected? And this is one of my favorite examples of a transport atlas that was published, I think, almost annually for a couple of decades by the French Transportation Ministry, inspired by kind of Minard's representations of flows. And so, I've always wanted to see if we can emulate some of the really great stuff that these historic cartographers have achieved. Can we emulate that through our own kind of more data-heavy approach, computational approach to cartography? And the real revelation for us came during the creation of that first book, London, the Information Capital, because somewhat foolishly, we had signed up to deliver the book of 100 maps and graphics. We had a year to do it. That's how long the publisher gave us. And a year sounds like a long time, but then you realize that what you're essentially trying to do is going from something like this, which is a spreadsheet of data, to your finished spread of data every 3 days, which is a very challenging work rate at the best of times. And even more challenging for someone like Oliver, who came from a background at National Geographic, where they might have spent, and they still do spend, up to a year working on a single map or a single project. So how do you get into that mindset of moving, of being able to compress time so quickly and so efficiently in order to maintain certain standards, but also deliver the maps that you need? And so that's really where sort of the programming came in, and taking advantage of the software element that was being developed at the time, and of course the data and the data standards. And so for that particular graphic, the reason I use it is commuting flows. It's the same data that I showed you in that final data shine example. It meant that we could actually create some code that generated the map for us. And why that was so important was actually the data we needed for this particular map wasn't released until like 2 days before the book was due in. And so what we were able to do was set out the layout, use some dummy data, put the labeling in, the styling in, all that kind of stuff. And then at the last moment, I could just press go on some software that generated the flow map you see above here. And then Oliver could then just drop that straight into our layout, and the map was done. And so we really developed a kind of a process between us that took kind of advantage of both our respective skill sets. So we really, we worked through the idea, the data sourcing, formatting, cleaning, exploration, doing the initial plotting, thinking about the layouts, final plotting, doing an export, and then the final design. And the groups, the things I've grouped together in the gray boxes are where all the time was saved through more programmatic approaches. So not doing stuff manually, but being able to use computer software and code to optimize what we're doing, such that it kind of liberated time, it liberated resource in terms of Oliver, for him to focus on things like layout and design and the kind of the stuff that makes all the difference when we're trying to create our maps. And so there's a couple of examples here where I just show the process. So here is the map, the plot on the left is how I kind of export it, and the one on the right is how it was finished. And you can see here that there's actually been fairly minimal intervention. We've just kind of sketched out the Greater London Authority and added some labels and changed the colors. In other cases, the final map or graphic can look somewhat unrecognizable compared to how I did the exports from the software I was using. In this case, it was a software called R. And you can see at the top here, we've just got a plot that shows this is age distributions by gender and marital status, and then a simple choropleth map here. And as far as Oliver's concerned, and the work that we do together, he doesn't care what the colors are and everything that I'm giving to him. I don't need to think about that. I just need to make sure that he has it in a vector format that he can then work with. And so these different components can get exported, and then we assemble them on the page. He doesn't have to draw any of the lines or anything manually, because it's driven by the data. And so there's kind of some innovation here in the way that we're thinking about working as equals. He designer, me geographer, working kind of through the big data analysis that I have to do, and then get over to him for the design. And so we wanted to apply that innovation in a context that hadn't had any before, and that's really what Where the Animals Go was all about. And the reason why that was an opportunity to really innovate was because biologists, or the biologging community as they're now called, were going through, or still are to a certain extent, going through this amazing technological revolution where they have all these tags and sensors that they can attach to animals, these animals can then generate enormous data sets. So if you wanted to know, where a bumblebee went, you had to chase it around a field. Now you don't have to do that. You can attach a tiny tag to it that will collect the data, broadcast it back to a base station, and suddenly you've got rows and rows and rows of data about the animal's location. Similarly, the sensor I'm holding on the left there is one that they attach to whales, and that one sensor generates gigabytes of data just in a 12-hour period. And there's some other examples here. So biologists and biologgers were starting to think about how they visualize it. And so a number of labs have these kind of big data walls and things like that that show the metrics that are being generated. So this is just something from a bird, an eagle data set just over a short period. But they didn't remain terribly accessible. I mean, these were the kinds of maps that you would see in scientific publications. We talk about them as being big hairballs, huge volumes of data mapped, but in quite a complex way. There's no kind of narrative there. There's none of the things that we would take seriously as cartographers in order to help people contextualize and understand that data. And so, Oliver and I got to work trying to disentangle some of those hairballs and create stories from them. And this was a very early draft of a graphic where, instinctively, Oliver wanted to pull out a single story or a single track of a particular seal, in this case, because this is a seal story about seals. And so in that case, we actually opted to get rid of the hairball as the main feature and just have a single story about a single animal called Rudolph, and where it swam and to the Antarctic Peninsula, and then made it off to the Falkland Islands before his tag fell off and stopped working. And so we can still, there's a strong narrative here. We can explain what the data is about, we can explain what it reveals, but we don't need that enormous hairball. And we can also combine it with many other contextual layers, those things that we're used to seeing on maps to help bring the story alive. So bathymetry data, which is now widely available, the ice shelves and the terrain, the labels, and so on. Our hairball remained actually, but as a much smaller inset that we colored by a seal colony. So you still got a strong sense of the volume of data that was being collected, but actually from a reader's perspective, you could tell the story you needed just from one animal. And so revealing structure and story is something that we've been very keen to do as kind of data sets have got bigger and bigger. And my favorite example of just how crazy things have got is this video here, which is actually an ant colony. So each of the ants in this colony has a tiny QR code glued to its back, and then, like the Truman Show, there are these cameras that are focused on the colony, and you can actually track through image recognition technology, you can actually track the ants' movements and behaviors. But there's no structure emerging here, of course, because it's dynamic, and we don't know what the data looks like when it's frozen in time. And so that again is an example of where what we would think of as a sort of cartographic representation, a map, is so powerful and can be such a game changer in revealing stories in complex data sets. So this is a visualization that we produced from that data set, where you're able actually to determine the kind of the job that each ant is doing, whether they're a nurse, a cleaner, or a forager. And you can actually see that structure in the nest by coloring the ants according to the role that they have at that particular moment, and showing the different elements to that. As ants progress through their life, they start off as a nurse, they become a cleaner, and then they finish their lives as a forager, leaving the nest in search of food. And so that brought me back thinking about human data, because actually ants, don't have much say into whether they track themselves, but actually people track themselves regularly and create huge amounts of data from that. And it's the same kind of technology. And so this is a map of cyclists that we did using a fitness app called Strava that we did for the London, the Information Capital book. Again, an example of a new kind of data set that previously didn't exist, but now we can visualize, showing where people with the app are cycling, how fast they're going, and so on. And this actually was again a kind of an innovation at the time, because it enabled you to get some sense of how busy certain cycle routes were without having to count people at the roadside. But this map is devoid of some context, and that's something else that has really come available now thanks to satellite or remotely sensed imagery. And this is my favorite example of that we're able to pull together for the animals book. The data set's the same, the format, or at least the format is the same, which is locations, trajectories of something. The previous map was cyclists. This one just happens to be of snowy owls. And what the data revealed here was that snowy owls were spending a long time over lakes in the Great Lakes. And this was strange behavior, because normally they spend their time over fields hunting voles and mice and that kind of thing. But here they are over the Great Lakes. And it was only by looking at their movements, but also seeing the conditions on the lakes, that the researchers realized that the owls were using ice and ice flows as platforms to then hunt waterfowl. And this is such a great example of how proper sort of cartographic context is important, because we were able to source a Landsat image for the period that the owls were on the lake, and so that there was ice on the lake that the owls were using. Now, of course, if you just used a basic Google map or any kind of generic base map, that context is gone. It would be blue for water, and the map wouldn't make any sense. So being able to combine those data sets, the context plus the movement, has been a real innovation, and something that we can do routinely and quite easily now. And we can actually track more and more objects automatically. So this is a data set that was kindly provided by the British Antarctic Survey, who tracked the iceberg A68 as it broke off from the Larsen ice shelf. So this was kind of done manually. Its shape was traced, but there's all these other icebergs in blue that are being tracked automatically from satellites now. And so the combination of satellite imagery, computer algorithms, and kind of data generation has created a very rich set of data that we can use and map, and can only really be shown on maps. And the technology now gets combined in other ways. We're not just tracking icebergs, we're tracking fishing vessels, combining that with contextual data about their location. And you can actually get kind of live maps almost of fishing intensity in the world's oceans. You can highlight potential illegal activity, and you can create maps such as this one to alert people to where the most kind of exploitation is going on in the world's oceans. And so there's a real coming together of ideas about how we can take these enormous data sets, how we can visualize them, and how we can kind of share them. And this was the idea that sat behind this kind of visualizing the invisible idea, which is what we used to title the final book, Atlas of the Invisible. And so that brought together a whole series of innovations and thinking that I've just described to you. So the idea that you can map kind of new data sets, and that the kind of analytical processes behind the maps are just as important as kind of the maps, the cartographic representations themselves. So this is mobile phone activity data in the Washington, DC area. And we can actually explain to people how you can effectively aggregate your data from points to a grid cell of varying size, and how that can have an impact on the representation and why that's important for people. We can harness some of the kind of new satellite data sets that are out there. So this is something that, you know, is published, a typical kind of scientific publication, graphic or map that you see quite routinely. Here we are showing ice speed on the Greenland ice cap. We can actually take that data and we can create our own visualizations of it by combining traditional layers cartographically of terrain, of the ice sheet itself, and then generating flow lines to give a sense of dynamism that people can see on the map. And those, you know, kind of bring it alive in a way that, you know, the more static looking things that you'd often see in the scientific papers. And so this is kind of an exciting development that was only really fairly recently made possible because we have so much data available for us. And in addition to that, we have computational processing power that, you know, there's stuff I can now do on my laptop that I couldn't have done 5 years ago. And things like taking a data set like this, which is a huge kind of hairball of global flights data that has all kinds of discrepancies and issues with it. You know, if you zoom in, you can see the level of detail we have, but also the amount of mess that's there. We can process it, or I can process it on a server that has many more kind of processing cores than I was able to access a few years ago. And actually you can create kind of cleaned up representations and start to think about how we might lay them out on a page in such a way that conveys a powerful message. So this is one of those examples actually where having the courage to do less actually created a better map. And here's an early draft that shows a week of flights over Europe, and I've colored them by the elevation that the flight is at. And so higher altitude planes are in darker colors and lower altitude are lighter, and you get kind of a firework effect. But actually the message we were trying to convey was just how busy our skies are. And so black and white worked really well for this. You can adjust the line thickness and transparency, generate that kind of image, and then the final map, you know, gives you that sort of cartographic, artistic feel that you know, it works so well kind of on the printed page. And you can really kind of begin to see how the kind of the traditional aspects we have here can be pulled together with some of the enormous data sets that are now available. So this was a data set that showed historic bombing campaigns in Vietnam and Cambodia during the Vietnam War. Historic data derived from paper maps, digitized into data sets that are enormous, but then filtered, processed, cleaned up automatically, plotted in this way. And then actually we've done subtle things like the original CIA terrain maps have been digitized and georeferenced. So we're actually using those here as part of our base map texture on both these maps. We're combining the kind of historic cartographic representation with some of the more contemporary stuff we're able to do. So that's a nice kind of nerdy point that most, probably 99.999% of our readers won't appreciate, but I know that I hope that the British Cartographic Society will appreciate that kind of subtle nod to some of the historic mapping that went on. So just by way of kind of finishing up, I wanted just to briefly talk about kind of the future sort of cartographers aspects, you know, what the next decade is going to look like. And the reason I say that, or I want to talk about that briefly, is just because it's something that, you know, I do every day at UCL when I'm teaching students and trying to attract them. And the big thing here is that kind of data science is here to stay. And there's huge demand for people that can work with large and complex data sets. But crucially, that demand really peaks with people who can explain them in a way that is accessible, that can tell a compelling story, and actually that kind of makes sense. And of course, that's what cartography and map making is all about. And so combining the data science skills with the cartography skills has proved quite a popular formula. And actually, I 5 years ago, my talk 5 years ago to the British Cartographic Society was why cartographers should code. And it's something that I think is fundamentally important and has actually saved cartography in my institution, at least, because I've been able to combine data science with cartography and data visualization, and it's created much more demand. So my module I started, it's called Cartography and Data Visualization. It started 3 years ago, and we've gone from 15 to 75 students enrolled on that in 3 years. And what's so powerful about it is you're able to teach them the classics, in a sense, the stuff I referred to, the kind of pioneering work, and how those pioneers actually can then interface to kind of sensible data and methods work that we see today. And the students really enjoy and respond to that. So I think kind of the technical aspects of cartography, remain, but also understanding how to work with big and complex data has never been more important. And so I just wanted to, say, well, has big data changed anything, particularly over the last decade or so? I mean, I maintain that cartography has always been the act of distilling the complex world into a map. It's this idea of abstraction. How do you take huge amounts of complex information and put it on a sheet of paper or a computer screen in a way that's understood? And big data has not actually made the world itself in reality any more complex. It's just given us more raw material to work with. And so the fundamental challenge remains unchanged, but the approach we use to tackle that challenge has evolved, and actually, I think, to our great benefit. And I think, the challenges are greater in terms of things that we are facing, the problems that we need to solve. And cartography has an answer to some extent. It enables us to show complexity, to show specificity, as well as generality. And this is my favorite example of that from our Atlas of the Invisible book, which shows the climate stripes. You can't miss climate stripes. They're all over the news. They're a brilliant innovation. The blue to red barcode that shows the heating that we're seeing. But they give us a single global view, or they don't tell us where things have got warmer, where things have got even warmer. And, we can do that with a map, and you can actually create maps that show that not only, we had heat waves in the 70s, there was a heat wave in 1976 or whatever in Europe, but that was an anomaly in a sense. It was a splotch of red on a blue planet. Whereas today, those heat waves are, splotches of dark red on a red planet. And being able to communicate those differences, how exceptions still exist, but they're more exceptional and even more challenging in different parts of the planet, or what maps are so good at. And I think that's something that we need to respond to now that we have so much data available to us and so much need to visualize it. So it was quite a rapid run through, but I'm going to leave it there. I'm going to say thank you for your attention. And I think we've got a few minutes for questions. So I'd be more than happy to answer any questions if people have them. Thank you all very much.
James, thank you. That was absolutely brilliant. I'm sure that's got cartographic juices flowing amongst people who are listening to you. Anybody got anything they would like to ask? While people are thinking about it, James, let me just ask you one question, if I may. All this data that you're getting access to, do you feel at times that the nature and the way that it's collected, it has its own built-in biases? And can you do anything about that?
Yeah, it's a very good question. So I kind of mentioned in passing that social media data, for example, I feel like social media data has kind of peaked and then it's now less widely used. And that is a classic case of the biases becoming a problem. So when it first came out, there was loads of excitement that we can, see these really fascinating things about the population. But of course, then people realized that, not everyone's on social media and there's lots of people who are missing from it. And the companies have particular biases and things that have changed and so on. So actually they're sort of, their currency has devalued as a result of that. And people are looking to new and other data sets. And I think that, the value of mapping them actually often very quickly reveals, where those biases are and those problems. So, we work with a lot with consumer data sets, and things like mobile phone data is a big thing, particularly in the pandemic, and seeing where people are and their interactions and so on. If you stick that kind of data on a map, straight away you can see there are certain parts of the country that, there's loads of data, and other parts of the country there's none, but we know people live there. And so showing those differences, showing that on a map is so much more powerful than, just tabulating it or whatever. So, I'm always keen to use as much data as I can, but we'll always caveat it where possible, and only if I'm confident that I'm representing enough that, the people I'm keen to represent, because yes, it's easy to overgeneralize for sure.
There is a question.
Yeah, I'm just having a read. Thanks, Ken. Slightly odd question, but in academia, the focus has always been journal publications. Have you been able to forge a career at top university who would ordinarily be interested in papers and funding? That's a very good question, Ken. So basically, the subtext of the question is, most universities, or in fact, nearly all universities, the kind of the things that give you credibility and kudos as an academic are not writing popular or so-called popular trade books and all that kind of thing. So I've been fortunate that I've been able to, I think, balance grant writing and paper writing sufficiently with keeping those outputs ticking over alongside the book stuff. So actually, I do feel like I have a bit of a hidden life there working on those sorts of things. I'm also very fortunate that my timing is right, because the demand for these skills is so high now that I was in a bit early to it. And so there's one of the few people around, particularly in social sciences, who have the kind of the skill sets needed. So I think that's, I've become somewhat invaluable, even if I do say so myself, but to the institution in terms of the stuff that I'm teaching. And it's actually very hard to find people that can replace me at this point, but there's loads of people coming up now. So, it won't be long, but that's, I think, the big, making myself somewhat indispensable, I think, has been a really important part of my strategy, at least. Okay, questions coming quick and thick and fast. Bob Barr, is there one example that best shows how MAP has led to change of government, local or national policy? That's a good question. I think in terms of stuff that I've done, certainly I don't know about the policy context, but the life expectancy tube map has been one that definitely has resonated with policymakers and others. I've had lots of emails about that. Data Shine has been a big policy one as well. But the challenge always is you never hear about it. You know, it's used and then no one ever tells you they used it. But I know that it was used in things like the Heathrow consultation and Crossrail and High Speed 2 and all that kind of thing. So that would be the one I probably would hang my hat on. The DataShine web maps, probably of all of them, has been the most valuable in that context. I'm just having a quick read of the other questions. So David's asking about whether it's the cartographer's responsibility to deal with biases, or you know, whether you take stuff at face value. The metric I use is if I was on the Today program and I was being interrogated on the map, could I defend the data that I've used in the map? If I can't defend it, or if I don't feel confident enough in defending it, then I'll either find out more or I'll disregard it. But part of that thinking process has always been getting my hands on the data, at least sifting through it as best I can. But you're right, I think there are some responsibilities in representation and not taking stuff at face value. Jim has a question quickly about mapping animal movement. Whose idea was it? Oliver actually had that idea because at National Geographic, he'd had a lot of more and more stories were coming through the magazine about these innovations in biology and animal tracking. And so his inspiration was a story about some elephants and the animal, their movements being tracked. And we realized that there was potential, you know, there's many other examples of that. And then the final question was, I've just seen, is from Paul asking about, we have another book idea to look forward to. Oliver and I don't have our own idea at the moment, I think, but we are working on another atlas as we speak with some colleagues at the University of Oxford. And so there will be more, we are making maps together, but it's not specifically our project. We're kind of cartographers for hire on that one, and helping them visualize their data. So watch this space on that sometime in the next couple of years. Oh, Liz, how do you put QR code on a map? I think with tweezers and a lot of patience is how they got the QR codes on. Great, so we're bang on time, I think.
James, that's brilliant. Thank you very much indeed. It was really fascinating. Really appreciate your time.
Thanks for inviting me. And if anyone has any other questions or follow-ups or anything else, by all means, drop me a line. I'm more than, love to hear from you.
Brilliant. Thank you very much. Well, that ends that part of the evening.